All right, exercise 6F. This sheet only has 2 examples because I'm revising what 6BCD is again. So last time, before the drill session, I went through some examples, 4 examples with you, and most of you got the idea. We're doing the same thing again. So someone had their hand up just now? Which one? All of them. Just one each. All right, let's start off with this first one. So we've got 6x cubed, so let's write it out. I've got y equals 6x cubed plus 11x plus x minus 4. On a logical sense, you only need to find x-intercept, y-intercept. Let's find y-intercept because that's the easiest one to find out. First, y-intercept. What do you have to do to find the y-intercept? What do you do? Yes, Anthony.
Wait, is there 11x supposed to be squared?
Yes, you're right. Thank you. Put a square here. I forgot to put a square there. There should be a square there. Square here and square there. How do you find the y-intercept again? What do you do? Artie? Let x equal to 0 because we know the y-intercept occurs when it touches the y-axis, and at the y-axis, x is 0. So we know that x has to be 0. We don't know what the y-coordinate is. But that means if you sub it into this equation, if you sub x equals 0, what would y equal to? Come on, team. It's pretty straightforward. Negative 4. Because all of them is x, all of them 0. So clearly, you get negative 4. So that means the y-intercept we already know negative 4 is one of the intercepts. Cool? Next one. X-intercept is what you've been training to do. 6BCD is essentially the skills to find the x-intercept. How do you find the x-intercept? We know that. What do we know? How do you find the y-intercept? Let's go with Zoe. How do you find the y-intercept, x-intercept? Good. So same theory. Y-intercept is when x is 0. X-intercept is when y is 0. So this is what you've been trying to do. If you let y equal to 0, you get 0 is equal to, you got 6x cubed plus 11x squared plus x minus 4. This is not easy to do. That's what I know how to do. And that's why you've been learning to factorize. But to factorize, we use 6c to find a factor. So remember, our goal is to break this into 3 brackets. You got to find the first one. So how do you find the first one? So a reminder of Tuesday's session, exercise 6c. What do you do? The Muffy. Ooh, you can. That's going to be the rational root theorem, but we don't do that one. We do instead not the 6, but we do the 4. So take the constant. We then ask the factors of 4. Factors of 4 is 1, 2, and 4. So the numbers that we will test. Exercise 6c, we're using remainder theorem or factor theorem. So I'm going to write here remainder / factor theorem. That theory just simply says when you sub in the number into this, whatever the answer is, that is your remainder. The numbers we're going to test are positive 1, negative 1, positive 2, negative 2, positive 4, or negative 4. Reason why we do that, because even though I don't know what's inside these brackets, I do know it would have to be x times x times x to get that x cubed, right? But then to get this last number, this doesn't have an x. That means these 3 numbers here, they have to multiply each other when you expand the brackets. They have to give you 4. So whatever those numbers are, it could be 1 times 4 or 1 times 1 times 4. It could be 2 times 2 times 1. I don't know. That's why I'm testing 1, 2s, and 4s. Okay, because somehow I'm getting that number 4 at the end. That's why we do that. Okay, so let's test the numbers now. We're going to test, starting off with the smallest number, I've got 1, so I'm going to test x equals to 1. Then you will get now y is equal to 6 times 1 cubed plus 11 times 1 squared plus 1 take away 4. Is this likely to give you 0 or not? Let's have a think. That's 6 plus 11 plus 1 minus 4. Do you think that's going to give you 0? No. I can already see too many pluses. Can't be 0. You don't need to work out what the number is. You just need to guess roughly. Next one. Let's try x equals -1. That means you now have 6 times -1 cubed plus 11 times -1 squared plus, what was this one again? Oh, -1. Whoops. -1 and then -4. Let's have a think. That will give you a -6. This will give you a +11, so that's looking good. That's a -1, -4. Does that give you 0?
Yeah.
Yeah, it does. Okay, so -6 minus 4 is -10. -10 minus 1 is -11. -11 and +11 does give you 0. So that means we now know x equals -1 is the one that makes it 0, but what's the factor? What goes inside the brackets? Yes, Anthony. Very good. It had to be x plus 1. Yeah, so that's what you learned from chapter 3. It was x plus 1, and you were to equate it to equal to 0. Clearly, x would have equal to -1. So x plus 1 is a factor. If it's a factor, it's called factor theorem. If it doesn't equal to 0, then we call it remainder theorem. Same technique. Okay, so factor theorem is the same thing. It's just when it's 0, we're like, it's a factor. So this is called factor theorem. So now that we know x plus 1 is a factor, we're almost there. We can now get these two. What do? So now we got the factor. What do we do once we have a factor? How do I get the next two? What do you have to do again? 6b. What was exercise 6b about? What was 6b again, Ben? The long division. So we know this is your number. This is a factor. If you take a number divided by a factor, you get the other factors. Here's the logic. If I gave you the number 24 and you found out one of the factors was 6, then when you do 24 divided by 6, you will get the remaining factor. True? 24 divided by 6 gives you 4. 4 is a factor. That's what we're doing. We're taking the cube divided by the linear. That's why we get a quadratic, and that quadratic has to be a factor. Has 0 remainder. That's why we do that. Yeah? So 6b, we're essentially saying, oh, okay, well now since I know 6x cubed plus 11x squared plus x minus 4, if I divide it by x plus 1, that should have 0 remainder because I know this is a factor. It has 0 remainder. If it has a 0 remainder, what is the quotient? What does this end up being? Now I taught you 3 different ways to do this. First way that your study design wants you to learn is polynomial division. So this is one way. So x plus 1. How many x plus 1s fit into 6x cubed plus 11x squared plus x minus 4? Here we go. Let's practice your polynomial division. Here we go. What number do I multiply to x to get you 6x cubed? What number can I please have Sion? So I'm saying something times x gives you 6x cubed. You got to be able to do this.
6x squared.
Thank you. 6x squared. It's not that you don't know. You got to stay on tune here. So 6x squared times x will give you 6x cubed. Fantastic. But then 6x squared, you also need to multiply to the 1. 6x squared times 1 gives you positive 6x squared. What do you do next? Now you know this is how many times it fits in. What's the next step? What's the next step of the algorithm? Minus, you find the leftover. So long division, you find the leftover. This gives you 0. 11, take away. I should put brackets around here to remind you that you're taking away both numbers. So 11, take away 6, gives me now the new line, which is 5x squared. What do you do next? Here's my remainder. How do I continue the algorithm? What do I do now? Can I please have, let's go with Akisha. What do you do next? So minus, I got that. What's the next step? Beautiful. Drop down the x. And now you start again. So you say, all right, let's do it again. What number do I put here to multiply to x to get 5x squared? What number should it be? 5x. So here should be plus 5x. I should make this a bit smaller. What's going on, my... Oh, there we go. Let's make this a bit smaller just so it doesn't look too confusing. There we go. So 5x. So 5x times x will give you the 5x squared you want. Don't forget to do 5x times the 1, which is plus 5x. Same drill again. Find the difference. Find the remainder. Cancels out. I'll put the brackets around this. 1x, take away 5x. What's 1x, take away 5x? What do you get? Luke? Minus 4x. So this now becomes minus 4x. I should do it all in blue color. Keep it all the same. 0, minus 4x. And then finally, same thing again. Drop down the last number. Minus 4. What's the last number here? Let's go with Lillian. What number do I multiply to x to get you to negative 4x? Minus 4. Beautiful. Minus 4 times x gives you negative 4x. And then minus 4 times 1 gives you minus 4, which is what we should expect. It should be the same line at the end. That's why when you take it away, it should all equal 0, which we expect it to be 0. If you don't get a 0, you've done something wrong. You either done something wrong in the substitution before, or you've done something wrong here. That's how you check. Okay, so it should have been a 0 remainder. Because a 0 remainder, we know it's a factor. This is your quotient. 6x squared plus 5x minus 4 is the quotient. That's the remaining factor. So if I zoom out now, and maybe I'll just make this a bit smaller so you can see. Here we go. Let's make this a bit smaller. There you go. Keep it neat. Now, we've done 6c to test to find a factor. We've done 6b to find the remaining factors, which is here. See, this is what we wanted. We've got the first one. You just found the second one. But it's not in 2 brackets, only in 1 bracket. So the bracket was 6x squared plus 5x minus 4. Was that right? Yeah, thank you. From here, how do you get your next 2 brackets? Because remember, our goal is to find x-intercepts. Don't lose your goal. The goal was always y equals 0. And if you can break this into the smaller factors, you can solve. So here we go. What is 6x squared plus 5x minus 4 factorized? This is chapter 3.
2x minus 1, 3x plus 4.
All right, let's check that. 2x times 3x is 6x squared. Good. 2x times the 4 gives you 8. And then you got minus 3 does give you 5. So that's true too. And then negative 1 times the 4 does give you negative 4. That is correct. Okay, so you factorize it. That's where chapter 3 comes in. That's why you learnt that in year 9. You learnt in year 10. You had to be masters of it by this point. And if you're not, you get another practice. So if you didn't do well in term 1 with chapter 3, this is your second time when you get to practice it again. Here we go. This implies what? What does the x-intercepts then equal to? For the first bracket, x must equal to negative 1, which we already knew because we already found it here before. So x equals negative 1 is one of the answers. What's the next one? 1/2. Very good. Sorry, yeah, there we go. So if you made that equal to 0, move the 1 across, divide both sides by 2, you get a half. And the last one must be? Beautiful. So if I ask you to sketch this graph now, we've got x-intercepts, we've got y-intercepts. Y-intercept was 0, negative 4. So let's just put here 0, negative 4. I've got a point on the y-axis. The x-axis, I've got negative 1/2 and negative 4/3. Negative 4/3 is a negative 1 1/3. So it's a bit further than the negative 1. So let's say negative 1's here. Negative 1 1/3 is probably over here, but I'm going to space it out so that when you draw it, it makes it easier. Negative 1 1/3, which is negative 4/3. I'll just change that to negative 4/3. And then the other one was half is in the positive direction. So let's just say half is here. So you might ask now, well, how do I draw this graph? Remember, even if I don't teach you what a cubic graph looks like, how would you draw without lifting your pen off the paper to cross all 4 points? You see, even if you tried to do it wrong, can you do it? Yeah, even if you try to do it wrong, even if I went from this down, so cross 1, 2, there was no way that I could have crossed this x-intercept and then come back. Get me? That's why I know the cubic graph can't be a negative version. That's called a negative cube, right? How do I know it's negative? Negative means that as you go further that way, the number keeps going down. Positive cube is the other way. As you keep going to the right, it continues to go up. That's a positive cube. Okay, so I don't need to teach you positive and negative, just simply trying to connect this. If you had to cross all x-intercepts and the y-intercept, there's only one way. 1, 2, 3. Whoops, what happened there? Let's do it again. Just draw 1, 2, 3. Oh, I think the thing knows that if I scribble, it just cross it off. But you got the idea. What you're missing is you just don't know where the turning points are. Okay, so you don't learn how to do turning points until end of year. I can teach you how to find those. But at the moment, this is all you need. Y-intercept, x-intercepts labeled. And then how did I know it was this shape? There's only one way to connect them. Otherwise, this is what you need to know. Look at the number in front of x cubed. See x cubed? What's the number in front of x cubed? 6. But is that positive or negative? It's positive. And like I said, there's only 2 types of cubics that you can draw because there's only 2 ways that you can draw so that you cross the x-axis 3 times. This is how you draw it. You go once, twice, 3 times. That's the only way you can cross the x-axis 3 times. This is called a positive graph. So when you have a positive number in front of x cubed, it'll look something like this. When you have a negative graph, so if I had a negative 6 instead, then it would have been 1, 2, and then 3. This is called a negative graph. So one looks like an N, and the other one looks like an upside down N. Okay, so that's one way to remember it. Or if you understand the logic to it, as you go to the right, if it goes up, it's positive. As you go to the right, if it goes down, it's negative. Okay, so 6E will talk about the different shapes that you can have of a cubic. But this is your raw form of a cubic. Cool? That's your general sense. So far, so good? Because I'm going to get you to practice the next one. Same drill. I want you to find y-intercept. I want you to do what we did in our Tuesday session. See if you can factorize it into this point. So you have to use 6B and 6E. And then have a rough sketch of what you think it should look like. Okay? Have a go with the next one. I'm going to pause the video and then we'll go through the answers together. Recording from here as well. Is this recording? Cool. So, same thing. Y-intercept should be 0, 4. X-intercept let y equal 0. Find your factor. If you test the numbers, 2 should have been the one that works. So that means x minus 2 is a factor. So everyone should have got the first step, x minus 2. Next one is you need to divide this cubic by x minus 2. I'm using a third method now. So you can do synthetic division, but just in case you prefer division by inspection as well, use the other way. Since you're dividing by x minus 2, the method is you write x minus 2, x minus 2, x minus 2. And all I had to do was I just did by inspection. This is all I do. So I say, what do I times 2x to get 10x cubed? Clearly it has to be 10x squared. Then all I do is I just say, well, the next one after x cubed is the x squared. So 10 times negative 2 is negative 20. How do I get negative 21? Negative 20, I need a minus 1. So I just write minus 1x, because that's x squared, that it becomes x now. Negative 1 times negative 2 will give you positive 2, but I need 0 x's. So currently I've got a positive 2x. How do I have no x's? I need a minus 2. And then double checking, minus 2 times minus 2 does give me the positive 4. This is called division by inspection. It's shorter, it's cleaner, but it does require a bit of algebra that I did in my head to match, because I'm matching it. I'm just doing 10x squared times x, 10x cubed. 10 times the negative 2 is negative 20. I know I need an extra minus 1 to get to negative 21. Then I take the negative 1 times the negative 2. That gives me positive 2 x's, but I have no x's here. So positive 2, I need to take away 2. So the negative 2 times the x, that's how I get minus 2x. And then minus 2 times minus 2, I just check if it's the same as the last constant. That's easier because if you factorize it, x minus 2, whatever's in blue, is a quadratic factor. This is called division by inspection. It is cleaner, can do it for most things, but it requires a bit of algebra in your head. Otherwise, polynomial division works. Okay? So you should be up to this step here. You've got now 10x squared minus x minus 2. And hopefully You factorized it. What is this? What? 5x, 2x, and you need a -1. So maybe 2 goes here and 1 goes there. So I'll need a -5 and a +2. That feels right. Yes. -5 + 4. Yep, that's cool. That all works. So can I get a show of hands who got the x-intercepts were 2, -2 on 5, and 1 on 2. Hands up if you got those. Well done. So that's 6B, 6C, 6D. Now 6F is just tying them all together. So 6F, put it all into the graph. Here we go. Y-intercept is 0, 4. So it's got a point up here, 0, 4. X-intercept's at 2, half. So half is, maybe I'll just do half here. 2, let's quadruple it. So maybe up here. 2, and then -2 on 5. Well, maybe I'll just do it here. Now, if you have to draw this, again, there's only one way to draw it, or you can look at the number in front of x cubed. It's +10. So I know it has to be an N shape. So you can expect the graph to look something like that. Not 100%, because we don't know where the turning points are, but that's not required. You just need a rough sketch. Y-intercept, x-intercepts. Make sure to label that in coordinates. Don't leave it like the way I have. But you should write it as -2 and 5, 0, half 0, 2, 0. You want to be careful. Draw an arrow on each end. That's 6F. How's that feel? Pretty good? Because as you're doing 6F, you're also training 6B, 6C, 6D again, which is a good thing. That means you then consolidate not only chapter 3, you consolidate the new things I'm teaching you. And this is one of the key steps, 6B, division by inspection or polynomial division or synthetic division. This is the theory. 6C is just about finding a factor. 6D is solving. 6E and F is sketching. So far, so good? All right, so that's the goal. You want to get here. This is the idea. As you're copying that down, we're going to then, I'm going to get you to grab out your notes that I gave to you on Tuesday that has 6A, B, C, D, E, F. We're going to go to look at those notes so that I can give you all the variety of equations you can get for a cubic graph. Okay? Let's go. I'm going to stop